Welcome and thank you for always joining our discussions. We are looking at quadratic graphs, and the first part of the question we have reads, draw the graph of the function y is equal to 2x squared plus 6x minus 5 by taking the integral values of x to be between -4 and +3. The first thing I usually do, it is to start by looking at the turning points of the curve so that we can be able to know exactly where that particular curve is going to turn. In this case, the function we have is y is equals to 2x squared plus 6x minus 5, and we know at turning points, at the turning point of any curve, the differential function of that curve would always be equal to 0. That means we are going to differentiate this function, that is 2x squared plus 6x minus 5. The dy, that is the change in where our change in x is going to be, 2 multiplies down so that we have 4x, you less 1 from the power, and when you differentiate 6x, it is going to give us plus 6, and this one is equated to 0. That means 4x is going to be equal to -6. If you divide both sides by 4, the value of x is going to be -6/4, which is the same as -1.5. Once we have the value of x, we can get y. By substituting x back, we are going to have 2 times x, which is -1.5, but it is squared, plus 6 you multiply by -1.5, -1.5, which is x, minus 5, and this one is going to give us a value equivalent to -9.5. That means the point here, the point is going to be -1.5 and -9.5. This is the point where our curve is going to turn. It is not a must that you show the working, but at least when you are plotting your graph, you must clearly plot that turning point for you to earn a mark at that particular point. Once we have this, we now go and construct our table so that we can be able to use the table in drawing our curve. We can bring this point here, that is the point of intersection. The point of intersection is going to be -1.5, -9.5. Then I want to use this upper part here to draw the table. So we are going to make a table having the values of x and y. The values of x are ranging between -4 and +3. So we begin with -4, -3, -2. Then before we go to -1, we have -1.5, which is our turning point, and -9.5. -9.5. Then we have -1, 0. After that, we go to 1, 2, and lastly 3. After we have the values of x, we can now use them to get the values of y. Then we go to the table direct. When the value of x is -4, you come and substitute it here so that you can get the value of y, and the value of y is going to be +3. When x is -3, you get -5. When x is -2, you get -9. When it is -1, you get -9. When it is 0, you get -5. When it is 1, you get +3. And when x is 2, you get 15. And when x is 3, you get 31. From there now, we can go and start our plotting. The highest value of x to the left of the origin is -4, and to the right of the origin is +3. Now we can go and use a scale of 1 centimeter to represent 1 unit. And on the y-axis, the highest value we have is 31 positive and -9.5. So we can try and lower our graph so that we can be able to get exactly what we need for us to draw this graph. So we are going to take this point. We are going to take this point to be our origin. From there, we are going to use 1, 2, 3, 4, 5. Then we have -1, -2, -3, up to -4 there. Because the highest value we have is 31, we can decide to use one box to represent 5 units. That is, we are going to have 5, 10, 15, 20, 25, and lastly we have 30 here. This is our y-axis. Our x-axis is here. Then downwards we are going to have -5, -10, -15, up to -20 there. There is no problem. After that, we can now start plotting our points. Here we can quote our scale. We can quote our scale and say on the x-axis, 1 centimeter represents 1 unit, and on the y-axis, 1 centimeter represents 5 units. From there now we can go and start plotting. When x is -4 here, the value of y is +3. +3 is that is -4, 1, 2, 3. +3 is here. When x is -3, y is -5. -3, we go to -5 here. When x is -2, then y is -9. -2, it is -9. When x is -1.5, -1.5 is around this point here. So the value of y is going to be -9.5. This is at this point here, and this is where our curve is going to turn. And when x is -1, it is -9. Again, -9 is here. So the curve has started turning at that point. When x is 0, that is when x is 0, it is -5. When x is 0, -5 is here for y. When x is 1, it is +3 at this point here. When x is 2, it is 15. 15 is here. And finally, when x is 3, it is 31. 31 is somewhere around this region. Here, our curve does not actually fix that point. After doing all that, we can now join all the plotted points as follows. join all the plotted points by connecting all these points. So we are going to have to connect them this way. After joining all our plotted points, we can now move down and answer the given questions. So for part one of the question, we are supposed to use our graph to solve the following equations. The first equation we have is 2x squared. It is 2x squared plus 6x minus 5, which is the same function that we have used to draw this. And in this case, we are going to get the solutions by looking at the points where the curve is intersecting with the x-axis. So at this point here, we are going to have to pick the value here, which is going to be 3 point. So at this point, x is going to be negative 3.8, and the other value of x will be obtained from this point where the curve is intersecting with. We have this point here and this point here. So in that regard, the value of x at this other point will be positive 0 point, that is 23, around 0.6 there. Those are the solutions for part 1. Then in Roman 2, we are supposed to solve 2x squared minus x minus 6. So we are going to take the main function, which is y, being equal to 2x squared plus 6x minus 5. We subtract the other function, which is 0 is equal to 2x squared minus x minus 6. Whenever you subtract these two, y will be equal to, we are going to have 7x plus 1. From there, we make a table having x and y. So the value of x, we assume, if x is 0, then you substitute it here. The value of y is going to be 1. And when x is 1, the value of y will be 8. And when it is 2, it is going to be 15. Those 3 points are enough for us to draw the line. And therefore, we are going now to pick the values of x from where the line and the curve intersect. So as part of the plotting, when x is 0, when the value of x is 0, here, y is 1. When x is 0, y is 1 at this point. And when x is 1, y is 8. When x is 1 at this point, y is 8. That is here. And when x is 2, y is 15 at this particular point here. Now we can draw a straight line joining all the 3 points as follows. Points. We can now move down and get the solutions. And the solutions are going to be the points where our curves intersect. You must always indicate how you have picked this point. So x is going to be positive 2, and the other value of x is going to be at this point. So you can simply move up here and get the value as negative 1 point, around negative 1.8, and that is the solution for this particular problem. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.